Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 3 from the June 2022 Cambridge IGCSE 0580 paper 4 variant 2. And this question here is about straight line graphs. It says a line L joins a point F and G. Coordinates are given. Calculate the length of the line. So we want to find the distance between F and G, and that's found using the formula which we should know, which is based upon Pythagoras' theorem, which is the change in the x, which here is 3 minus 5, but squared, plus the change in the y, which is 2 minus 4 squared, and then square rooted. Okay, that's based on Pythagoras' theorem. If you'd like to picture what's going on here, so you can understand it better, you could think about a diagram. You wouldn't have to do this in the exam, but just for you to maybe get a better idea of what's happening. Like minus 5, 4, for example, might be a point over here. That would be the point G. Minus 5, 4. So that would be negative 5, and that would be 4. Not really to scale. And F would be 3, 2. So say that's 3 and that's 2, 3, 2, something like that. Okay, that will be F, 3, 2. What we're trying to do is we're trying to find the distance or the length between these two points. Trying to find the length between these two lines, or these 2 points, sorry. The length of the line joining these 2 points. So what we've done here is we found the change in x. The change in x basically gives us this distance over here. That's a change in x. And the change in y gives us that distance over there. So basically what it does is it forms a right angle triangle. This distance is 8. This distance is 4. So we can then, this distance is 2, not 4, because that's 2 and 4. Okay, let me just make this distance is 2. So we can find by Pythagoras' theorem, which this is based on, the length of the line segment. That's what this formula does. It automatically applies Pythagoras' theorem to this type of question, right? So you don't really have to draw the diagram. It's just illustrating what's happening. So 3 minus 5 gives us this distance here, which is going to be 8. So that's going to be the square root of 8 squared plus, and that's going to be, that distance is 2. It doesn't matter about being negative. When you square it, it's going to become positive. That's going to be like minus 2 squared, which is going to become 4. So you end up with the square root of 64 plus 4, which is the square root of 68. Okay, which you should write to 3SF in the end. So we take our calculator, and we write it to 3SF. If you want to, just make sure that we haven't made a mistake here. We're going to have 3 minus 5 squared plus, so 2 minus 4 squared under the square root. That gives us 2 root 17, which is basically the same as that, because that's 34 times, root 17, because that would be 34 times 2. Okay, that would be 17 times 4. So root 4, that's right, root 68. So when we write this to 3SF, which will give us 8.246, 8.246. 8.246 continues. So we write our answer as 8.25. So 8.25 units. It didn't tell us centimeters or anything, so just leave it as 82.5 without any units. That's fine. So that is the length of the line between F and G. Okay. Sometimes I'll say calculate FG. Like that. All right. That means the same thing, the length. Right, now, find the equation of the perpendicular bisector of the line L in the form y equals mx plus c. Now, the perpendicular bisector, what does that mean? Okay, so you have perpendicular, bisector is made up of 2 words. Perpendicular means at right angles to, bisector means cut exactly into 2 equal halves. So to find the equation of the perpendicular bisector, which would basically be a line which cuts this line in exactly 2 halves, and it passes through its center. So the perpendicular bisector would be a line that basically cuts through exactly the center of this line, okay, exactly halfway between, at its midpoint basically, and at right angles. So we need 2 things. we need to know the midpoint of the line. Okay, now the midpoint of the line is given by finding the average of the coordinates. So xf plus xg divided by 2 and yf plus yg divided by 2. Okay, so the midpoint is going to be given by the x coordinate of f, which is 3, plus the x coordinate of g, which is 5, minus 5 divided by 2, and the same for the y coordinates, 2 plus 4 divided by 2. You add them, and then you divide by 2. You're finding the average, basically. So this is 3 minus 5, which is negative 2, over 2, which is negative 1. Okay, and this is 2 plus 4, which is 6, divided by 2, which is 3. So that's the midpoint. So that's one thing we've found, the midpoint. And the second thing we need to know is the gradient of the line that we're trying to find. Now, the gradient of the line we're trying to find is not the same as the gradient of the line that we're given. The gradient of the line that we're trying to find is going to be perpendicular to that gradient. So first of all, we need to find the gradient of the line FG, which is, the gradient is the change in the y coordinates divided by the change in the x coordinates. So we're going to do y, you can say yf minus yg over xf minus xg. Okay, so yf, you can say 2, remember it's a y coordinate, minus yg, which is 4, over xf, which is 3, minus xg, which is minus 5. So 3 minus minus 5, be careful of the sign. That's going to give me 2 minus 4, which is negative 2, over, that's going to be 8, which is negative a quarter. All right, so that's the gradient of fg. So therefore, the gradient of our line is going to be the negative reciprocal. It's going to be 4. Why? Because the line that's perpendicular to the other line has a gradient which is its negative reciprocal. So you turn it upside down, so it becomes 4 over 1, and then you change its sign. So it becomes minus 4 over 1, then you change its sign, it becomes positive 4. So the opposite sign and upside down. So therefore now we can use two ways. I'll show you both ways. Students are normally more comfortable with the second way I'm going to show, but I like to show both ways. So we can use y minus y1 equals m times x minus x1. We now know the coordinate of the point, and we know the gradient. We're looking at these two things. So we can say y minus the y coordinate, which is 3, equals m, which is 4, times x minus the x coordinate, which is negative 1. Okay, and we want to write it in this form in the end. So I'm going to just write y minus 3 equals, that's going to be 4x. This is going to be plus 1 times 4, which is plus 4. Add 3 to both sides, so y equals 4x, and it's going to be plus 7. Y equals 4x plus 7 will be the equation of the line. Y equals 4x plus 7. The other way to do it is to use y equals mx plus c. We know m is, so we know the point it passes through is the minus 1, 3, and we know the gradient that we're using is 4. So we can say y, we can replace the y with 3, we can replace the m with 4, and the x with minus 1 plus c. So 3 equals minus 4 plus c. Therefore, c equals 3 plus 4, which is 7. So therefore, we can say y equals m, which is 4x plus 7. So there's the answer to part B of this question, the equation of the perpendicular bisector, which is quite a common type of question. And then finally for part C, it says a point H lies on the y-axis such that the distance GH is 13 units. Okay, find the coordinates of the two possible positions of H. Okay, so now G is what? G is this point over here. Okay, and H is a point on the y-axis. So let me just make a little diagram to make this a bit clearer so we can understand what's happening. So we know G is a point somewhere over here, which has coordinates minus 5, 4. So let's say minus 5 and 4. And H is going to be a point on the y-axis such that GH is 13 units. So let's make one of the possible positions up here somewhere. and the other possible position down here somewhere. Okay, so this is H, we can say 1 and H2. All right, so I know that these two are equal in length. So isosceles. Okay, that's one thing. I know that this length is 13. I know that this length is 13. All right, and I know that this length here is 4. From G to this point is going to be, sorry, minus 5. This is 5 units. This is 5 units. Okay, because G is 5 units away from the axis. Okay, so this is a right angle triangle. I can find the length here. I can find what this length here is in this right angle triangle. I can say that this length here, by Pythagoras' theorem, I can say that x is equal to the square root of the hypotenuse, 13 squared minus the shorter side squared, which is 5 squared. Now, I know I've got 5, 12, 13 triangle. I know it's going to come out as 12, but we can confirm that. That's 169 minus 25. That's the square root of 144. So we can say x equals 12. So I know that this is 12 units. So I can see, I know that this is the coordinate here 4. So we can say H1 is going to be equal to 4 plus 12, and H2 is going to be 4 minus 12. So H1 is going to be 16, and H2 is going to be minus 8. So the coordinates of them is going to be 0 and 16 and 0 and negative 8. Okay, that's a nice, easy way to do it. We could have done it in another way as well. I mean, I could have said that G has coordinates minus 5, 4, and H have coordinates 0, y. Okay, I could have done it this way. This is an algebraic way of doing it. So I'll show you also an algebraic way of doing it. I'll skip to this side and show you how to do it using algebra. Okay, this is like using a visual method, which I showed you here. Algebraically, we can also do it as well. We can say that GH equals 13. So if we know that the magnitude of GH is equal to 13, I can say that the difference in the x coordinates, you can say minus 5 minus 0 squared plus, and I can say 4 minus y squared has to give me 13 squared. Okay, I know that the square root of this is equal to is going to be the square root of 13. So I can just get rid of the square root and just leave them as squared. So I've got minus 5 minus 0 squared, that's going to be 25. Plus, I'll leave this in this form now because I think it will be easy to solve, equals 169. And then I can say 4 minus y squared equals 169 minus 25. So 4 minus y, if I take the square root of both sides, well, let me first, this is 144. So I got 4 minus y. When I take the square root now, I have to be careful that it's a squared. So I know that there's two possible answers. It's either plus or minus 12. The square root of 144 is 12. So it's either plus or minus 12. So we can say that 4 plus or minus, we can, if I want to just do it properly, I can say that basically 4 plus 12 equals y, or 4 minus 12 equals y. Those are the two possible answers. Okay, which gives us y equals 16 and y equals minus 8. Okay, 16 or minus 8. And so therefore, those are the same two answers that we got. So it's going to be 0, 16 or 0, negative 8. And that answers this question in a visual way and also an algebraic way. Both of those are perfectly acceptable ways of answering the question. And that's the answer to part C of this question. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from the topic of straight line graphs can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can find how to use my channel to find what you're looking for by clicking on the link over there. Thank you for watching, and see you soon.